Hi, Earth Science. Welcome to your review video. This should not be the only thing you're using to review for your quiz, so please make sure that you're also looking over your notes, your assignments, that sort of thing, and that you are well prepared for this quiz, because I'm giving you so many resources because I care so much that you really understand this, that if you don't do well on the quiz, I will be very sad. Okay, so let's look at these answers. So the first question was, know what energy is, how it gets to the Earth, and how it transforms. Remember that energy is different from matter because matter is made of atoms and energy is not. It's hard to define what energy is, so we just call it the thing that makes stuff happen, but it's not actually a thing. It's in physics, it's called the ability to do work, which still doesn't define it well. But we do have examples of energy, such as radiant energy or light energy, the electromagnetic spectrum. We have potential and kinetic energy. Hello. That's a physics term because I was helping someone with physics. Kinetic and potential energy, solar energy, thermal energy. There's many more, but those are some good examples. Almost all of the energy on Earth comes here from the sun. Remember that, okay? Very, very important. And the reason why energy gets here at all, why it exists, most of the universe is dark. So actually the natural state of the universe is to be dark. But the way stars work, they are doing nuclear reactions all the time, and a byproduct of that is light. And that gets to our planet, and there's so much energy locked up in light that it allows all of life to happen. So kind of a big deal. Okay, and it gets to us by traveling through space. Once it gets to the planet, it has to interact with the atmosphere, but we'll talk about that in a different section. Okay, so we gave energy. We talked about the thermal, the solar, etc. But remember, we also broke down the parts of light into this spectrum. We drew it as a straight line across, where we started with lowest energy on one side and we had highest energy on the other side, but I wrote it as a list here. Okay, so make sure you know which part does what, okay? So if we start at the lowest energy waveform, we have, wave energy, light energy, where the electromagnetic energy is, we're talking about things that we call radio and cell phone waves, and we've actually figured out how to code energy on those, and we send them around the world and even the universe. We try to send energy, these things out into the universe to talk to aliens. Do they exist? We don't know. We then get a little bit more energy. You're talking microwaves, which shouldn't actually hurt us, but because we're made of mostly water and the way microwaves work and the shape of water, not the movie, the way that H2O is shaped, microwaves exactly activate water by making them move around. And remember, as molecules move more, as they have more energy, you get higher temperatures. Okay, so the more motion or activation you have of molecules, such as water, the hotter something is. And this is great because we can use it to reheat chicken nuggets, but it's not great when you are exposed to microwave radiation at like intense parts of it, or intense doses, not what's in your microwave, you're fine, because it can actually activate the water in your body, okay? So the microwave energy in your microwave is not enough to actually hurt you, okay? So don't even worry. Same with cell phone radiation. It's such low energy, even though people are like, oh no, it's gonna cause cancer. There's been no evidence of this, and we've had cell phones for so long now, and radios especially, that we would know if it caused cancer, and it does not. Okay, there we go. But we could go into it more. I'm happy to talk about it later. Okay, infrared. Infrared is the expression, we call it heat. Okay, so whenever you are giving off heat, you're giving off infrared energy. Okay, that's a lot of animals can sense infrared energy, or the heat given off by an animal, and that's how they hunt. They then get into the visible light spectrum. So this huge spectrum, only a very, very small part of it is what we can see, and that's the spectral colors. Roy G. Oops, I forgot the B. But remember that there's not actually an I. So we say Roy G. Biv, but indigo is not a real spectral color. Isaac Newton made it up because he didn't like the number 6. And he's like, we need to have a 7th color in there, or else it's real awkward. And I like the number 7. It's my lucky number. And so he put indigo in there. It also makes it easier to say Roy G. Biv, but actually there is no indigo. Okay, other colors are either blends or they're just reflections and absorptions of different parts of that, so that we get things like brown and pink, okay? All right. We then get into ultraviolet. Ultraviolet, remember there's 3 different kinds of ultraviolet that we talked about. There's UVA, B, and C. UVA goes deep into your skin and can cause wrinkles and cancer. UVB only affects the top layer of your skin, which causes you to tan unless you don't have enough melanocytes, those color cells that release a darker chemical so that it will absorb that light so that your DNA does not. Oh, interesting. Albedo versus absorption. But some people don't have enough of those, so their skin doesn't get dark at all, and they burn instead. So this is a literal burn if you get a sunburn, okay? This can also cause cancer. UVC can also cause cancer. We don't know a lot about it because we don't have a lot of it on our planet, because thankfully the ozone layer protects us from it. So when ozone is in the stratosphere, it absorbs a lot of high energy stuff coming from space, starting with UVC. Everything above UVC gets absorbed by the ozone layer. Thank you, ozone layer. We would be dead without you. Oops, there's holes in it. We're going to talk about it. X-rays are very high energy light that can cause many kinds of cancer because they get in, and when they go through you, they get in, they mess up your DNA, and your DNA tries to replicate. It gets all messed up. Cancer. Okay. But in small doses, you can recover from this. And that's why we use it in medicine and dental practices, because it allows us to visualize the hard parts inside of our bodies that we would not be able to see without cutting someone open, which is very invasive. Okay. Getting even higher than that. So we can create x-rays. There are ways, we won't get into it. But the x-rays from space don't usually get to our planet. They get absorbed by that UV radiation, ozone layer and other parts of the atmosphere. Thank you, thermosphere. The gamma particle, the gamma rays, not the same as gamma particles, very different. Don't let my confusion just say that. Gamma rays are very, very, very high energy. When they're part of the highest part of the spectrum, they have such high energy that they definitely cause cancer when they get to you, or they can just kill you straight up. So the Hulk is a lie. But fortunately, again, the atmosphere absorbs the gamma radiation from space and protects us. Okay, excellent. Boo. Albedo and absorption. Remember, we talked about when sunlight gets to the planet, it has to interact with the planet, and it can do so in one of 2 ways. It can either hit a surface that is some percentage of white, and then instead of interacting at all with that surface, it just reflects straight back into space. Okay, and so no heat is released, the sunlight doesn't change, it's just light, done. If you've ever walked outside long before when theaters still exist, and it was really bright outside, and there's white concrete, and it hits your eyes, you're like, it's so bright. You're experiencing albedo. Okay. But once it hits your eyes, it's absorbed, and then some heat happens. Okay, cool. When sunlight interacts with non-white surfaces, some or all of that energy is absorbed. And anytime something is absorbed, you lose some energy as heat. Okay, so it's lost, which means it just goes into the universe. It becomes heat, which means we can't get it back. There's no way to get heat back. Okay, and so that's a problem when all of a sudden the heat, there's so much heat being created by the surface of the planet, and it gets trapped in the atmosphere. And that's a greenhouse effect we'll talk about in a second. The more efficient your surface is, or the machinery in your surface, the less energy is lost as heat. That's why solar panels can be dark but not hot, because they can take that solar energy and they convert it to different kinds of energy before it is lost as heat. Same thing with photosynthesis. Photosynthesis is the heat, the energy from the sun comes in, gets absorbed by this chloroplast and changed into sugar so fast and so efficiently that no heat is lost. There is some heat that is lost, but it's not anything more than our current body temperatures. That's why when you walk on grass, it feels nice and cool, but it's not frozen. Okay, excellent. The structures of the atmosphere, I'm not going to go into every single one because everything is available for you on this website. You go, you click, we talked about it in class, you go, you click down, there's all the things. I definitely suggest that you know these, not just this is a good thing for the Kahoot part of the quiz, where I'm like, this part of the atmosphere, it contains the ozone layer, and you'll be like, oh, stratosphere, woo, etc. Okay, this is the coldest part of the planet. Oh, it's the mesosphere. This is the hottest part of the planet. Oh, it's a thermosphere. Oh, but that's weird because there's so few molecules that on average it's cold, but the individual molecules are so hot because they absorb high energy from space that they are some of the hottest molecules on the planet. What? crazy. And remember that the exosphere is where we fly our satellites, and there's a lot of space junk because we can't recover those satellites, so they're just floating around unused, but full of very secret data that we don't want people to get a lot of times when they're spy satellites, and we just hope no one goes and gets them. But good news, it's so hard to go and recollect those satellites that no one is getting them. So that's atmosphere. Let's talk a little bit about weather. Some people in their atmosphere lab put some weird stuff happening up in the troposphere, or up in the higher levels. Remember that weather only happens in the troposphere. Anything higher than that, it's not weather. So if you've ever flown and you come out when the plane is ascending and then it levels out for cruising speed, you're above the clouds because the plane always travels on the bottom of the stratosphere, especially for longer flights. If it's a shorter flight, it might not get that high because it doesn't need to before it starts to descend. Remember, so if you're above the clouds, you're in the stratosphere. That means weather must happen below you, so it's happening in the troposphere. Okay. You can also, there are gases in the troposphere that act as greenhouse gases, and those are gases that trap heat. And so examples of those are carbon dioxide, methane, which is farts, and ozone. Oh, but ozone protects us from space. Yes, when it's in the stratosphere or higher, but when it's in the troposphere, it's not getting that space energy. It's getting the energy from the planet, and it traps that energy and then releases it as heat into the rest of the planet. Oh no, so hot. Which would be fine. We actually need the greenhouse effect to survive, because without greenhouse effect, the planet would be 100 degrees colder and we wouldn't survive. If it was 100 degrees colder, today was like 85, so it'd be negative 15. I don't like that. So we need the greenhouse effect, but the problem is the greenhouse effect is causing the planet to heat up much faster than life can adapt for, and that is a problem. This should be life, not live. Cool. Okay, so what the clear correlation being that the more greenhouse gases we release into the atmosphere, the more heat is trapped, and also the production of greenhouse gases also releases heat, and so that's it's like spiraling in itself. The more greenhouse gases are released into the atmosphere, the hotter the atmosphere gets, the more intense the weather gets, because you're heating up the troposphere. Okay, so as the troposphere gets hotter, you get more intense weather events, and that's a question in a few seconds. Okay, when ozone is in the stratosphere, remember again, we have troposphere and then stratosphere. So if there's ozone in the troposphere, it's capturing the heat from below. If there's ozone in the stratosphere, it captures heat from above, which is all the cosmic radiation coming from space trying to kill us. And so thankfully that ozone layer is around our planet in the stratosphere, except where there's holes, and it's grabbing all that cosmic radiation, like gamma radiation from the sun, so that it doesn't get to the planet. But where there are holes in the ozone layer, because of chemicals that were used in the 80s and before that, those holes are allowing that cosmic radiation to come to the planet and kill things, and that is a problem. So we are hoping it is actually healing, but is it healing fast enough to protect life? We're not sure. Okay, so what kinds of gases and other things are in the atmosphere? Remember, go look at that page to look and see what other kind of things are in the atmosphere. But in general, what they are there. When we say air in the troposphere, we're talking about a mix of nitrogen gas, oxygen, carbon dioxide, argon, some other gases, and then dust and water vapor. Okay, so these are very important. You have to have these for clouds. We'll talk about that later. That's what is present in the atmosphere. Okay, naturally. If we put spy satellites or planes or weather balloons, that's different. But naturally, the atmosphere is full of these gases, dust and water vapor. All right, what evidence do we have that climate change is real? Okay, I want you to focus on the climate. So what examples have you found? So many people from my generation like to say, it's not even real. Now, we no longer debate whether or not it's real. It's obviously real. You watched in the temperature anomalies video, you watched that everything is getting hotter. There's no way to say that that's not real because we have records of it. It's data. It's not bias, right? But the question now is it natural, or is it something that we are doing, or is it, in either way, can we do something about it? So the question then is, why do we care about it? And we care about it because as the troposphere heats up, we see more examples. So I'm going to write that down. As troposphere heats up, we see, where'd it go? We see more examples of extreme weather. And this is where you need to give specific examples. Extreme weather events. So we talked about there's more hurricanes. We currently are worried about Hurricane Delta in the Gulf of Mexico right now. We didn't used to get to the Greek alphabet. So the way hurricane naming works is it goes first hurricane of the season is named, has a name starting with the letter A, and then the second one is B, and then C, and then D, all the way through the alphabet, which means if we're in Hurricane Delta, that's not number 4. We've gotten into the Greek alphabet. So now all of a sudden we've gone through all first 26 letters. We don't start over. We instead go into alpha, beta, delta, blah, 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 whatever it is. Okay, so that's either the 3rd or the 4th. I don't remember how the Greek alphabet works. I don't know if there's a C. I think there, anyway. So now we're looking at the 26th, 7th, 8th, or 9th hurricane of the year, and it's only October. It's not over yet, and so that's very crazy. That's not supposed, I mean, in recorded history, we haven't seen that before, except for last year and the year before that. And then, you can see as you go back through time, there's less hurricanes and they have less damage. Same thing with wildfires here. Wildfires happen, but not as often as they are now and not as intensely as they are now. Also, diseases. The more climate change we see, the more likely we are to see horrible pandemics. So last year we had Zika. Before that we had SARS. Before that we had swine flu. And now we're dealing with COVID. So the more climate change happens, the more exposure we have, and the more likely that more people are going to die from major diseases. Okay, so that is another good example of how we know climate change is happening. We're seeing evidence of it every day. I already answered this, so that's up there. Well, greenhouse gases, remember that's carbon dioxide, methane, ozone. The greenhouse effect is how those gases, when they're in the troposphere, trap heat coming from the planet and then send it back down to the planet. Where did they come from? Carbon dioxide comes from burning of fossil fuels. Methane comes from farts. And so you might be like, what? Who cares? Flatulence. But think about the number of cows that have to exist so that people can eat their In-N-Out. That's a lot of cows. If you've ever traveled up the I-5 to get to San Francisco, you go past huge slaughter yards, and they are full of so many cows. And that's actually a small amount of cows. Now, take that times however many states there are, however many pastures there are in the state, however many countries are raising cows, and that is a significant amount of methane that is heating up the atmosphere. This is why the idea of meatless Mondays is important, because you have less methane being produced and therefore less greenhouse effect. Okay. All right, so the last question, think about your sit space and how it affects your attitude about your environment. Now, there's a lot of evidence saying that if you want someone to care about the environment, get them out in nature. They're more likely to care. If someone's never been in nature, they probably don't care about it, or else they would have been out in nature. The more you're in nature, the more exposed you are to just sitting there and the relaxing effect of being out in the clean air, the more likely you are to care about things like climate change. Okay, so think about that kind of thing. If you hated your sit space, you're doing it wrong, because there is a natural calming meditative effect of being out in nature, and humans thrive best when they are allowed access to things like forests or beaches or whatever that's outside. If you raise someone only inside, they have a lot of issues. Okay, there horrible experiments have been done, and so think about, if climate change is not letting us go outside, are we being our healthiest selves? What a good question for the quiz. All right, y'all. Good luck. See you later.